Hello friends, just check the 2016-17 paper, the NMS term 2 paper. In that, n of a minus b is 14 plus x. Can you see that? It is the 2016-17 paper, term 2. N of a minus b is 14 plus x. N of b minus a is 3x. N of a intersection b is x. Also given Na equals Nb. The question is to find the value of x. Now to do this, we are going to make two circles. Draw two circles, and this is going to be the Venn diagram method. So let us draw the two circles, and in the two circles we are going to show what is n of a minus b, n of b minus a. So these are the two circles. So circle 1 is A, circle 2 is B. So in that, let us now fill up the details. Where is 14 plus x? So this is set A, set B. So 14 plus x is only A, that is A minus B. So put 14 minus x or 14 plus x, sorry. Then B minus A is 3x. So observe, put 3x only on B. And now you put A intersection B, the join of the two, which is x. That will come in the middle. So inside A, now you have 14 plus x. And inside B, you have 3x plus x. So what is A? A is equal to 14 plus x. And what is B? X plus 3x. So n of b is 4x. Now you are going to equate the two because they have given n of a is equal to n of b. So 14 plus 2x is equal to 4x. So that's how we get the value of x as 7. That's how we do this question number 7. Now we move on to the 10th question. In the 10th question, they have given that G is the geometric mean between A and B. G is the geometric mean between A and B. And P and Q are arithmetic means between A and B. P and Q are the arithmetic means. And let us see what exactly we have to prove in this question. G square is equal to 2p minus q multiplied with 2q minus p. This is what we want to prove. Look at it, inspect the box. G square, to prove that G square is equal to 2p minus q, 2q minus p. Now we are going to do the typical LHS RHS method. What is G square first of all? G square is equal to AB. We know that G square is equal to AB. So the left hand side is AB. We now have to prove that the right hand side is also AB. Now let us see what is the right hand side. So we have A, P, Q, B in arithmetic progression, which means P is A plus D, Q is A plus 2D and B is A plus 3D. So we now know these three quantities. So we are just going to substitute this on the left hand side, on the right hand side. So the right hand side is 2 times what? P. P is A plus D. So 2 times A plus D minus Q minus A plus D. Correct? And 2 times Q. Q is how much? A plus 2D minus A plus D. Now you open this bracket and solve this. And once you solve this, you're going to get the answer as A into A plus 3D. Now once you get A into A plus 3D, isn't that what we want to prove? Because B is nothing but A plus 3D. So that's how we prove LHS is equal to RHS. So, g square is AB, g square 2p minus q and to 2q minus p, that is also equal to AB, therefore, they are both equal. That is the way to do this question. Now, look at the 14th question. In the 14th question, you want to convert 2x minus 3y plus 7 is equal to 0 to the normal form. You want to find, that is, the normal form is x cos alpha plus y sin alpha equals p. That is the normal form. And you also want to find alpha and p. Alpha is the angle the normal makes with the line, with the positive x-axis, and p is the perpendicular distance from the origin. We need to find these two quantities. So, let me remind you that this is a line 12x minus 5y plus 7 equal to 0. The normal, which is the red line, makes an angle alpha. Now, we need to find alpha. We also need to find the length of the red line, which is p. So 12x minus 5y is equal to minus 7. Now, since the right hand side is minus 7, bring the minus 7 back to the left hand side. So, minus 12x plus 5y is equal to 7. Now, you divide both sides with root of a square plus b square, which is root of 12 square plus 5 square. Both sides you divide root of 12 square plus 5 square. This is how we convert the general form to the normal form. So, you are going to get minus 12x plus 5y by 13 is 7 upon 13. Now, you split it as x into minus 12 by 13 plus 5 into 5 by 13 is equal to 7 by 13, which only means that cos alpha is minus 12 by 13, sin alpha is equal to 5 by 13. So, p is 7 by 13. So, we have converted it to the form x cos alpha plus y sin alpha equals p. Now, they are asking us to find alpha. Now, in this case, you are going to find tan of alpha. Now, tan of alpha is sin alpha by cos alpha. So, sin alpha by cos alpha, you are going to get it as minus 5 by 12. Therefore, alpha is tan inverse of minus 5 by 12. Alpha is what? Tan inverse of minus 5 by 12. And p, the perpendicular distance, is 7 upon 13. So, tan alpha is, alpha is tan inverse of minus 5 by 13. That is the way we write. We always write it in the form of tan inverse, not sin inverse or cos inverse, but tan inverse. Check your notes in the class, we have done this part before. That is the way to convert the general form to the normal form. So, ax plus by plus c is equal to 0. When we want to convert to normal form, it is x cos alpha plus y sin alpha equals p. So, we divide both sides with root of a square plus b square. The next question, the hypotenuse of a right angled triangle, this is the 28th question, has its ends at point 1, 3 and minus 4, 1. Find the equation of the legs of the triangle. Now, this is actually a wrong question which has been given in your exam. This is also there in the textbook. It is a miscellaneous exercise question, I think question number 17 or something like that, but it is an incorrect question. Why? Because using this information, you will never be able to find the coordinates, you will never be able to find the equations. However, we are going to make some assumptions, and that is how the answer in the textbook is given. So, I am going to tell you based on the assumptions how to do this question. So, let me tell you first why this is impossible to do. Suppose you have minus 4, 1 and 1, 3. You are drawing a right angle triangle. How many right angle triangles are possible? There are actually infinite right angle triangles. Let me show you a few of them. This is one right angle triangle. Now, you try to draw right angle triangles, you will get one more like this. In fact, there will be infinite right angle triangles. they will all lie on that circle. So since you cannot find the values or the equations uniquely, we are going to make a few assumptions in the question. We are only going to find out that right angle triangle which the sides are, one of them parallel to the x-axis, one of them parallel to the y-axis. So the question is to be changed. So let me draw the x-axis and the y-axis. Now we have the 2 points -4, 1 and 3. Now we are going to draw two lines, one of them parallel to the x-axis, one of them parallel to the y-axis. Now parallel to the x-axis, the red line, that is one line, and parallel to the y-axis, the blue line. So we will try to find the equations of these two lines. Now think a line parallel to the x-axis passing through 1, 3. This is going to be of the form y is equal to 1. So the two lines will be y is equal to 1 and x is equal to, y is equal to 3. So the equation is going to be y is equal to 3 and x is equal to -4. So the answers to these lines are the horizontal line. Horizontal line means only y. So y is equal to 3 because it passes through 1, 3. And the vertical line, the blue line, is x is equal to -4. So these are the two lines, one of them parallel to the x-axis and the other parallel to the y-axis. So the red line is going to be y is equal to 3 and the blue line is going to be x is equal to -4. Stick to those. So that's how we do the 28th question. The line should read x is equal to -4, not x is equal to 1, sorry. X is equal to -4 and the red line equation should read y is equal to 1. Now, in the 15th question, read the 15th question, they are asking something about number of dishonest people. So in this, you have to show that, since you have to show that there is no dishonest people, we have to show that there is no term containing x to the power of 5. So we are going to try to find the coefficient of x to the power of 5. So in this, you first write tr plus 1 and try to accumulate all the x terms together and show that there is absolutely no term containing x to the power of 5. Now for doing this, no term containing x to the power of 5, we are going to accumulate all the x terms together and you are going to show that r is in fact a fraction. So if r is a fraction, there is no term containing x to the power of 5. You will get r as, I think, 17 by 3 because 22 minus 3r will be equal to 5. 22 minus, so r cannot be a fraction, hence there is no term containing x to the power of 5, which means that there are no dishonest people in that group. So this is just a cryptic question. The question can be translated to show that there is no term containing r x raised to 5. No term containing x to the power of 5. Thank you for watching.